Hey, PSTAT students, Mr. Mitchell here. Today, we're going to look at quantitative data and doing calculations with that quantitative data to describe and go through SOX. Talk about SOX here in a little bit. So let's get into it. Let me make sure I'm sharing my screen here. There we go. So we have this data represent travel time to work for 15 North Carolina workers chosen at random. So there's your data. Here's a stem and leaf. So that's what it looks like. It's the distribution from what we learned before. This is going to be, again, you have to turn it sideways. It's going to be skewed to the right. It's unimodal. It's got one peak. Looks like we got a potential outlier too. So that's all by looks. We could try to estimate the center. It looks like the center is right about here. Spread goes from 60 to 5, so it's about a 55 range. But now we're going to get into a little bit more detail, not just looks. So we got to be able to find the mean. So this is the formula to find the mean. You add them all up and divide by how many there are. So that's how you find the mean by hand, but we're going to learn how to find it with the calculator. We're going to learn how to find a lot of things with the calculator. Okay. So calculate the mean, boom. We indicated that 60 may be a potential outlier. Excluding that value, the mean for the other 14 people, we could find the mean without those. Okay, so sometimes you may exclude an outlier, but typically you want to include it. But sometimes you like to exclude it and see what it does to the mean. The mean is definitely larger when you include the outlier. The mean is sensitive to extreme observations, to outliers, okay? But it may also be influenced by a skewed distribution. So even if 60 is not an outlier, it is still going to affect the mean. It's called non-resistant, all right? So then we're also going to find the median. The median is the middle number. So you put them in order and then you count towards the center. So 15 is an odd number of observations, so the middle number will be 8. So the middle number is 20. So the median may be a better representation of the center here. All right. So sometimes you want to talk about mean, sometimes you want to talk about median, and it's good to have them both to try to make the comparison because it can confirm your thought about shape. The median is resistant to outliers or skewness. So when we have a skewed data set, typically we're going to use the median, not the mean, because the mean is affected and can start to change or skew. It's called skewed left and skewed right, skew your results. So then we also have to measure spread. So before we get into that, let's go to our calculator. So I already took this step of entering the data in for the travel time. So to enter data on your calculator, you click Stat, the Stat button, and then you click on Edit, hit Enter. You have these lists of data. You can type in as many lists as you want. Typically, students don't put that many data lists in there, but if you're repeating data sets over and over again, you can leave them stored in there. So I typed in all my data. You do not have to type them in numerical order. I feel like there's a few data points that are off me typing that in there. Let me just verify that those are correct. So we got a 5, and that last one is a 10. Yeah, I knew we didn't have 2 single digits. We did have a 5, though. Okay, sorry about that. So I think I fixed it. So you should have 15 data points. I think those other numbers. So you're going to just type them in, boom, boom, enter, boom, boom, enter. You just enter in all your data. And then to find the mean, median, and some other things, if you click Stat again and go to Calc, you select one bar stats, which stands for one variable statistics. You have one variable, one list of data, so it's one variable. You're going to tell it L1, and if you need to change lists, if you click the blue button and then there's the L1, L2, L3, there's the little blue above, you just hit second. Mine's already L1, so I don't need to do anything with that. Frequency list is something we'll do later when we get into probability. We don't need to do that right now. And then you click calculate. So there's your mean. Some of these other numbers we don't necessarily need right now. There's your mean. here's your standard deviation, which is going to be very important to us, the 15.23. Tells you your min, probably already knew what your min was just by looking at the data set. Then when you have your first quartile, there's your median, there's your third quartile, and then there's your max. So those are all going to be important to us, and we're going to need to keep those in mind as we move forward. Okay, so we already found and talked about mean and median, so now we know how to find those. So we're thinking about SOCs. So let me pull up a slide here. So S O C C S. So the first S stands for shape. So we've talked about the shape before. So that could be your skewed left, your skewed right, your roughly symmetric, your approximately normal, your unimodal, your multimodal, your bimodal, anything like that. Your O stands for outliers, and we already started to talk about those. So O is for outliers. You got to be able to calculate and find those. Sometimes you just eyeball them. So far, we were just looking at the judgment to see if they're outliers. The first C we have is standing for center. So that would be your mean and your median. That's really what that's focusing on. Your next C is for, that should be an O, is for context. So in every problem, pretty much, it has a context. We've got to talk about that context. In the problem that we're working on now, our context is mean travel time for North Carolina residents. Okay, so that's our context. And then our last S is spread. So we want to make sure that we talk about these 5 things anytime we're talking about a single distribution or multiple distributions if we're comparing them. So we always want to talk about SOCs. We want to talk about shape, outlier, center, context, and spread. The context can be dealt with anything else. You don't have to like write a book about the context, but when you're talking about the shape or you're talking about the spread, if you include the context, then you'll have that covered. Okay. So now we are talking about our spread. Some of the measures of spread are range. That's just the biggest minus the smallest. It's typically taught in like 7th grade. So range isn't too bad of finding. Quartiles and interquartile range. So we talked about our quartiles when I pulled up my calculator. My quartiles here, 10 and 30 were my quartiles of my data set. So how do you find the quartiles? You put them in order, put your data in order, and then you find the middle of the first half of data, and then you find the middle of the second half of the data. And so it's like finding the median. It's just you got to find half of the first half and half of the second half. And then your IQR is when you just subtract the 2 quartiles. So that's a measure of spread because it's measuring the inner spread between the 50%, the middle 50% of the spread. So here's the example with the North Carolina workers. We found our median of 20, but then to find the first quartile, you're going to find the middle of the first half. And then to find the third quartile, you're going to find the middle of the second half of data. Calculating outliers. So now it's not just an eyeball test. It looks like an outlier. It doesn't. I don't know. It's kind of maybe. This is confirming whether it's an outlier or not. So you take 1.5. It's always 1.5 times your IQR that you just found. And then you subtract it from the first quartile. So our first quartile was 15. We found that. And then you subtract off. Oh, that's for a different data set. Sorry. That's a New York worker. Okay. So we take our IQR. So let me pull up our data. Our IQR is, our first quartile is 10. So what I would do is take 30 minus 10, and that's 20. So then you take 20 times 1.5. So that's 30, right? 20 times 1.5 is 30. So then you would subtract it from 10. So 10 minus 20 is negative 10. So anything below negative 10 would be an outlier. Well, we don't have any outliers below because our min is 5. We then take our third quartile and add that number to it. So our interquartile range is 20 times 1.5 is 30. And then we add that. So 30 plus 30 is 60. So technically 60 would not be an outlier because it didn't go farther. Didn't go further. So, little AP exam tip, you may be asked to determine whether a quantitative data set has outliers. Be prepared to state and use the rule for identifying outliers. So we need to be able to do that. Okay, there's another way of learning about outliers or identifying them. We can talk about that at some other point when we get to it. Okay, so that's how you find outliers. So another thing, we already looked at finding the 5-number summary. The 5-number summary consists of, when I go to my calculator, my min, my first quartile, my median, my third quartile, and my max. That's what the 5-number summary is. So min, quartile 1, median, quartile 3, and max. And it breaks it down. We're going to make a box plot, and it's broken up into 25% into each quarter. That's why it's called a quarter of a dollar, 25%. So how do we make a box plot? You got to have a scale, and you're going to mark the first quartile and the third quartile. You're going to mark the median, and then you're going to mark the min and the max. If you have any outliers, you do mark them with a special symbol. So here's a data set for home runs and Barry Bonds. They found the median. They found the 2 quartiles. Quartiles are in between 2 numbers here because it was an even set. Then you have your min and your max. And then once you have all that information, you have a scale. The scale has to be the same. We're going by 5s here. You put your max, you put your min, you put your third and first quartile, and you put your median. The quartiles get a box, and the median's drawn in the middle of the box. And then your min and your max look like they have like little whiskers. Sometimes it's called a box and whisker plot. We just typically call it a box plot, but those would be like the whiskers, if you will. If there were any outliers, you would denote them with like a little asterisk or a little star. So you can also do side-by-side box plots to compare the socks. You can compare the shape. You can compare the spread. You can compare the center and any outliers. The context is typically going to be very similar, except for maybe which state that you're talking about. Okay. So as we said, North Carolina didn't have any outliers, but you can see this is New York had an outlier for how long they traveled to work. That was an outlier. Okay, that's what it would look like. So I'm not going to go through and describe each of them, but again, you want to talk about socks. Here, it's written in a different order. The order in which you do socks doesn't matter. Socks was created to try to make life easier on students. I don't have a ton of acronyms, but this would be one to try to help you. So we have our shape, we have our center, we have our spread, we have our outliers. And then within the whole problem, it's talking about the context. So if you do that, you don't have to have a separate section for context as long as you're hitting that. Okay. So if we want to make a calculator box plot, we could do that. We go to second stat plot. We go into one of the plots and we turn it on. And then we have to select box plot. So we can select, if you want to show outliers, you'll select this one. If you don't care about outliers, you select the second one. You tell it the list. We're doing it in L1. Frequency, just leave that as 1 unless it's something special. We'll talk about that if it ever gets to it. Your mark doesn't really matter. And then you graph it. And we got a bunch of stuff graphed here because I was using it for something else. So let me delete those. I graph it and you can barely see the box plot. If you can't see anything or barely see it, if you go to zoom and either zoom stat or zoom fit, I usually try zoom stat first and boom, there's your box plot. Don't worry if you don't have this table over here. Mine being the teacher's edition, it gets to put that on the screen. I don't know if there's a way to do that on your version or not. So there's my box plot. I can see what it looks like. I could see, where the middle is, where my quartiles, my min and my max. So I can make a box plot that way. Definitely something that you can do. Okay. A couple other things to look at and then we'll be done. All right. So the 5-number summary doesn't get used all the time. Anytime we have symmetric data, we always use the mean in the standard deviation. We can also talk about the variance, but usually we talk about standard deviation. So spread, we can talk about spread with range. We can talk about spread with IQR. Talk about spread with standard deviation, okay, or variance, but typically we go with standard deviation. So we found our standard deviation on our calculator, and there is a way to do it by hand. Let me go back. Now that I'm done with the box plot, let me pull up my standard deviation again. We can see it. So my standard deviation is 15.23, and my mean is 22. Okay, so just for simplicity's sake, let's just kind of we're going to round those off. Okay, let's just round those off. So I'm going to draw the normal bell curve. I'm going to try to make life a little easier for us. So let's just say, I know it wasn't exactly, let's just say our mean is 22 to make life easier. And so our mean is 22, and we set our standard deviation. Let's just say it's 15 to make math a little easier. So we don't have to worry about adding decimals and everything, so we can follow it easier. So 1 standard deviation each way, and then we'll have 2 and 3 standard deviations each way. So what you do is you add, it doesn't have to be a normal bell curve, but a lot of data is represented in a normal bell curve or approximately normal. So to go to the right, you add 15. So that'll be 37. And then you add 15. What's that going to be? Not 42. 52. Sorry about that. And then you add 15 one more time. That'll be 67. So this will be 1 standard deviation, 2 standard deviations, 3 standard deviations. Then we got to go the other direction. So you subtract 16, that would be 7. Subtract 15, what's that? -8. And then subtract 15 more, what's that? -23. I think I did my math right, hopefully. So this is our distribution that we would look at, and we can identify our shape. If we have our shape like this, we can identify our center. We can identify the spread. The standard deviation is 15. Can also identify any outliers. Anything outside of that would be an outlier. So if you're 2 standard deviations away, if you're further than 2 standard deviations from the mean, you are considered an outlier. So anything smaller than -8 and anything bigger than 52, we would consider an outlier. Okay. And so that's how we represent standard deviation. Okay. I wouldn't be too concerned with calculating standard deviation by hand. I would worry more about what does it mean? What does it represent? The standard deviation is the typical distance you are from the mean. Or you could say it's the average distance from the mean. So you take all the distances of all the points from the mean and you average them together. That's what the standard deviation is. It's the typical or average distance you are from the center, from the mean. Okay, so that's what we want to focus on with standard deviation, not so much on how to calculate it. That's not typically something that gets asked a lot. Okay, so we're talking about spread. Standard deviation is always a positive number. If you have a standard deviation of 0, it indicates there's no variation. All the points are the same. Standard deviation has the same units as the original observation, and it is non-resistant to outliers and skewness. So it gets affected. So if you look at my picture, when we have a somewhat symmetrical data set, whether it's normal or not necessarily normal, we typically use mean and standard deviation when things are symmetrical. When things are skewed, we typically use median and IQR to measure that. Okay, so we always want to plot our data, choosing measures. That's what I was just talking about. Are we going to use the mean and the standard deviation, or are we going to use the median and and IQR? That's really the question that we have to focus on. Skewed data or a lot of outliers, we're going to focus over here. Anything that's roughly symmetrical, roughly normal, or normal, we're going to use mean and standard deviation. If you had to say which one gets used more, it's mean and standard deviation, because a lot of data does follow approximately normal or symmetrical data. Okay. Okay. So if you have any questions, let me know.